Hi everybody, I'm sorry I can't be with you today, but I did want to teach you lesson 3. So today we're going to be solving radical equations that are word problems. So let's take a look at the first question. The speed in miles per hour of a car is given by s equals the square root of 30fd, where f is the coefficient of friction, d is the stopping distance in feet, and there's a table that shows the coefficient of friction for different surfaces. So what you're asked to find out is how much further was the stopping distance of a car traveling 45 miles per hour on wet asphalt compared to dry asphalt. So the first thing that you want to think about is what does each variable represent? So we have a coefficient of friction here, and they're really asking us to compare two different things. How much further the stopping distance of the car traveling 45 miles per hour was on wet asphalt compared to dry asphalt. So we're using dry asphalt and a wet asphalt value. So we need an F value for one part of the problem of 0.75. We'll call that dry asphalt. And separately, we need an F value of 0.30 for wet asphalt. Okay, now let's see what else we know. So D is the stopping distance in feet, and they told us that that's what we're looking for. So we're trying to solve for that D. Coefficient of friction we just talked about. It's going to be different for each part of the question. And speed, that's our S value, would be 45 miles per hour. So I want you to take a minute to pause the video to try to answer the question. Okay, let's go over question number 1. So we're going to use this formula, S equals the square root of 30 FD. And we know that S is the speed, which is 45 miles per hour. It's a 30 here. If we're trying to calculate for dry asphalt, my F value is 0.75. And the D value we don't know. For the wet asphalt equation, we're using that same formula, S equals the square root of 30 FD. Our speed is 45 miles per hour. But this time our coefficient of friction is 0.3. So we need to solve both of these radical equations. So the first step would be to square both sides to get rid of that radical sign. So 45 squared is 2025. And when you square a square root, they cancel each other out, leaving us with just 30 times 0.75D. And if you wanted to, you can now multiply the 30 times the 0.75 to get 22.5D. And now we're going to solve for D by dividing both sides by 22.5. So D is equal to 90. Same procedure when we're solving on the right-hand side here for the wet asphalt D value. We're going to square both sides to get rid of that radical. 2025 equals 30 times 0.30D. 2025 equals 9D. And if we divide both sides by 9, we get that the D value would be 225. Okay. So now, the question is asking how much further was the stopping distance of the car traveling 45 miles per hour on wet asphalt compared to dry. So now we have our two values, our wet asphalt value and our dry asphalt value. So now we just need to subtract. So 225 minus 90 would give us 135 feet further. Okay, let's take a look at question number 2. So we have this equation, s equals the square root of t minus 2t plus 6. Maybe we'll use a different color. So t here and here is representing time from the origin in hours, and s, where it is over here, is representing the speed of the tidal wave. So the first part of the question is asking us to algebraically determine the time when s is 0. So I'm going to replace 0 for s. I want you to pause the video and try to solve this equation for t. Okay, so in order to solve this equation, the first thing that you want to do is you want to isolate the radical sign. So I'm going to add 2t over to the other side of the equation and subtract 6. So 2t minus 6 equals the square root of t. Now to undo that square root sign, or to get rid of it, I'm going to square. So this left side would be 2t minus 6 times 2t minus 6. And this right side would just be a t. So here I need to double distribute. So I get 4t squared minus 12t minus 12t plus 36 equals t. So I really have 4t squared minus 24t plus 36 equals t. And then if I subtracted that t, I would have 4t squared minus 25t plus 36. So now this is going to turn into a factoring question. So I'm looking for what multiplies to 4 times 36 and adds to negative 25. So my two factors should be negative 16 and negative 9. So negative 16, negative 9t plus 36. So I'm going to factor this by grouping. So here my GCF is 4t. And here my GCF is negative 9. So I get two factors. One is 4t minus 9. One is t minus 4. So I'm going to set each factor equal to 0 to solve. I get t equals 4. And if I solve this side here, I get t equals 9 over 4. Okay, so don't forget, you have to check your answers to radical equations. So if you plugged 4 back into the original equation, it does check, but let me just show you. So if my original equation is s equals the square root of t minus 2t plus 6, s is 0. So if I plug in 4 for t, I would get 0 equals 2 minus 8 plus 6, so that's good. But if I check this other equation, or this other value I should say, 9 over 4 in my original equation, 0 equals the square root of 9 over 4 minus 2 times 9 over 4 plus 6, what's going to happen is it's not going to check, because 0 is not equal to 3 halves minus 18 fourths plus 6. So we need to reject this t value. Our only answer that we're keeping here is t equals 4. Now I'm running out of space, but there's a follow-up question. And the follow-up question is how much faster was the, whoops, I wanted the highlighter. How much faster was the tidal wave traveling after 1 hour than 3 hours to the nearest mile per hour? So that's just a plug-in part of the question. Let me just see if I can get a blank page here. Okay. There we go. Now we have a little bit more space. So for this part of the question, I'm going to rewrite my equation. And first, I'm going to plug in a 1 for t for 1 hour. So the square root of 1 minus 2 times 1 plus 6. So s equals 1 minus 2 plus 6. That's going to give me 5. Separately, I'm going to plug in a 3. That's going to give me the square root of 3. So now I want to know how much faster was the tidal wave traveling after 1 hour than 3 hours. So now I need to subtract. So that's a 5. 5 minus the square root of 3 should give me 3.268, on and on and on. Doesn't look like an equal sign. Okay. But the tricky part of this question is that answer is in hundreds of miles per hour. And so they're asking in miles per hour. So really what you're going to need to do is move the decimal 2 points to the right. So it would really be 326.8 miles per hour. But since they wanted you to round to the nearest mile per hour, it would really be 327 miles per hour. So thanks for watching today, everybody. And if you could work on the practice, that would be great. Homework tonight is number 3.